Hello, welcome to another day of polynomials. Today we're going to learn about synthetic division. Now we can use synthetic division to find all of the zeros in a particular situation. So in this situation we're going to find, we know that 1 0 is at x equals 2. And let's divide this out. So really that's like saying x minus 2 divided into this function, x to the third plus 5x squared minus 2x minus 24. Now, if I took a second and did this real quick, that would be x squared. Oops. So this would be 7x squared minus 2x. That is a plus 7x. So now I have 7x squared minus 14x. This becomes 12x minus 24. And if I put a 2 up there, that'll be 12x minus 24. Now, they found an easier way to do it. And this only works when this value out here doesn't have a coefficient in front of x. So this isn't saying that everything that we learned before is not worth it anymore. We still need polynomial division in other situations. There's a shortcut if there's no coefficient on x. And what we do is we put our 0, which in this case would be 2, in a little box, and we put the coefficients here, 1, 5, negative 2, and negative 24 out here. And I'll make my 24 again. That doesn't look very good. Now what we do is, first thing we do is we drop that 1 straight down. And now we multiply 1 times 2, which is 2. Now instead of subtracting like we do over here, we just add. That would be 7. 7 times 2 is 14. We add down to get 12. 12 times 2 is 24. Add down. It cancels out. Now notice that this is 1x squared plus 7x plus 12. So it drops from being x to the third to x squared. This goes from x squared to x to no value, and the thing without any variable, hopefully, if it divides evenly, won't have any value, or this would be the remainder. Alright, so now we just started the problem. We showed that there is a 0 at this value. Now to find the other two zeros, what we would have to do is factor this, if it factors. If not, we'd use quadratic formula. So what two numbers multiply 12 add up to 7? That's 3 and 4. So this function could be written as x plus 3, x plus 4. If there's a 0 at 2, that means it would be x minus 2. And the 3 zeros would be at 2. Our two new ones would be at negative 3 and negative 4. So those are all the zeros of this function. So that's actually what I just did. If I want to write this all using linear factors, that's what this is right here. X plus 4 times x plus, or x plus 3 times x plus 4 times x minus 2. That is called a product of linear factors. Now, use that to sketch the polynomial. So we have a few different values here. Now, if I want to sketch the polynomial, we know this crosses at 2, negative 3, and negative 4 on the x-axis. So 2, negative 3, and negative 4. We know this has a positive leading coefficient. And it's odd, so it should trend in this general manner. So we'll start down here. It'll come up, go down here. It crosses at negative 24. So it'll come down here, cross down there, and shoot back up. So we used our x-intercepts, we used our y-intercepts, and we used the degree in order to sketch this polynomial. Sure, it might be a little higher here, it might look a little bit different down here, but we know it passes through these 4 points and goes in this general pattern. Alright, now use synthetic division to find all the zeros in this situation. Well, we have a 0 at -4, so let's start there. So first I want to divide this out. Oh, I'm writing the whole thing out. All I need is my coefficients. So 1, -1, -21, 1, and 20. Now when I drop this down, that'd be 1. 1 times -4 is -4. This would be -5. That would be 20. Add it down to get -1. This would be +4. Adds up to be 5. That'll be -20. Now if it tells us that there's a 0 at -4 and I don't get this to cancel out, then we have a problem, because we shouldn't have a remainder if this is actually a 0. Alright, so this is now x to the third, x squared, x. I still can't factor that well unless I use this one. So I need to factor this again from my quotient. So from the answer that I got from my first problem, I need to see if I can get another 5 out of that. So we'll do synthetic division with what is left over. So that'd be 1, 5, 0, 0, -1, -5. And now that cancels out. So if this is x to the fourth, this became x to the third. Now this is x squared. So I have x squared minus 1. Can I factor x squared minus 1? Hopefully you're saying yes. That's x plus 1, x minus 1. So if I want to write this as a product of linear factors, we could say this is y equals x plus 4, x minus 5, x minus 1, and x plus 1. So now let's see how well we can draw this graph. It has zeros at -1, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So it's -1 and +1. It has zeros. At 5 and -4, it has zeros. And it says positive leading coefficient, and it is x to the fourth, and it crosses at 20. So somewhere on this, we have a 20. So it's going to come from the top, come down, sweep in here, something like this. That probably doesn't look exactly like that. Actually, I'm fairly confident that it doesn't look exactly like that. But we know it passes through those 5 points, goes up and to the left forever, goes off to the right and up forever. So this general pattern is what we're looking for. All right, now this one, try this one on your own and see if you can write this out. Find all the zeros, write it out as a product of linear pair product of linear functions, and then graph it. All right, so now hopefully you're done. So when I multiply this out, I have 1, 1, -1, -1, -21, -21, 45, 45, and that cancels out. Now my next row, I have to take a -5 off of what I've currently have. So this becomes 1, -5, -6, 30, 9, -45, and we're done. This is x to the fourth, x to the third. This would be x squared minus x plus 9. So I could write this out as y, x minus 1, x plus 5. This can factor into x minus 3 times x minus 3, so x minus 3 squared. Alright, So if I want to draw this out, I made two crooked lines. One is embarrassing enough. Two, that's just embarrassing. So this crosses out 1, and there's this double zero at 3, and then it crosses again at -5. It has, it crosses the y-axis at -45, so that's at -45. It is a quartic function with positive leading coefficient, so it's going to start from the top, somehow come down here, pass through -45, come up, and now it's going to do a double zero at 3, and then continue to go off to the right. Alright, so now we have one more problem for you to do. Pause the video and see how well you can do with this one. Alright, hopefully you're done. It has 1, 0 at -2. So that's 1, -2, 1, and 18. So 1 times -2, that'll be -4. That'll be 8, 9, and -18. So this would be 1x squared minus 4x plus 9. Now, if I want to write this as a product of linear functions, this is quadratic, so we have to simplify this. Now, there's not two numbers that multiply to 9 that add up to 4, so what we have to do is quadratic form. So negative b plus or minus the square root of b squared minus 4ac all over 2 times a, which is 2. This would be 4 plus or minus the square root of 16 minus 36. That's a -20 over 2. -20, first thing we do is we take out the I, and square root of 20 is going to be the square root of 4 times the square root of 5, or 2 root 5. So this would be 2I root 5 over 2, which will simplify to 2 plus or minus I root 5. So there's going to be 2 real zeros, 2 imaginary zeros. So my real zero, -2, so that's going to be x plus 2. Then this would be x minus 2 plus I root 5. X minus 2 minus I root 5. And this is writing it as a product of linear factors. Now, to actually draw the graph, now we don't know much about this graph without our calculator. What we do know is it crosses at -2, and that's the only real zero it's going to cross. It has a positive leading coefficient, so it's going to generally look like this. It's going to cross the y-axis at positive 18. But we don't know how this will affect the function. So let's just say it comes up, it's there, and turns around at some point and then comes back up. This could be a complex number. Sometimes there's a sharp turn, other times it just kind of isn't as sharp. This is tough to draw. You don't know exactly what's happening. But so when I check this on the test, I'm going to see that you went through here, and that the function is going to be going down to the left and ending up and to the right. All right, well that is enough to get to your worksheet. Good luck.